Hello everyone, my name is Simeon and I'm doing question number 41 on chapter 5. All right, to solve this problem, the first thing to do is to write down everything that's given. And what is given is 78.08% nitrogen. What else? 24.94% oxygen. 0.05% carbon dioxide and 0.93% argon. And they also give us volume, atmosphere, and temperature. And for volume, they give us 1 liter. For temperature, they give us 25 degrees Celsius. And they also give us atmosphere, which is 1 atmosphere pressure. And the next thing to do for this question is to find out what they're asking for. And in this question, they're asking for molecules. So make sure that when you're solving this question, that you should get molecules at the end, or you'll be way off. So how do we solve this? The first thing to do is look at what do they give us and what equation would give us the answer. And a good thing to ask yourself is, how do we get to molecules? And the only way to get to molecules is by moles. And how do we get to moles with the information they give us? Ideal gas law. Oh, no. Which is something you should memorize for your exam, which is PV is equal to nRT. And to solve, P is for pressure, V is for volume, N is for moles, R is a constant, and T is for temperature. So we must manipulate this equation to solve for moles. So we can manipulate it into PV over RT is equal to N. And from here, it's just plug and chug. So for pressure, we have 1 atmosphere. For volume, we have 1 liter. And for R. Now, just in case you get confused about which R to use, because you're giving 2 R's, the best thing to do is solve for R and find out what the units are. So for R, we can also manipulate this equation, which we can get PV all over NT, which is atmosphere times volume all over moles Kelvin, which are the standard units we should have, that we should input for this, for the equation. So we should know that for which R to use, which is 0.0821 atmosphere liters over moles Kelvin. So for any problem, make sure that you use the proper R. So again, for R, we have 0.0821, which atmosphere liters all over moles Kelvin, times temperature. Again, the standard units for temperature is Kelvin, and they give us Celsius, so we have to change Celsius to Kelvin, and which is 273 plus 25, which gives you 298. And from here, we plug into our calculator and we should get 0. 0 point. We should get 0 point. Sorry about that. 0.047 moles. 0.4087. Now we should get 0.4. 0.04087 moles air. And using this, we can use Avogadro's law, which is volume is proportional to moles, which is also the same thing as volume is proportional to molecules. So we can change the moles into molecules. And how do we do that? 0.04087 moles times, for every 1 mole, we use Avogadro's number. We have 6.022 times 10 to the 22nd power, and that gives us 2.46 times 10 22nd molecules. Oh, sorry about that. 6.022 times 10 to the 23rd molecules. And from there, we can use this equation. Volumes of nitrogen all over the volumes of air is equal to molecules of nitrogen all over molecules of air. And from here, we just solve for molecules of N, which is molecules of N is equal to volume of nitrogen times the molecules of air all over the volume of air, which we can plug in, which is 0.78 times the number of molecules of air, which is 2.46 times 10 to the 22nd molecules all over 1.0 volume of air, which should give you 1.91 times 10 to the 22nd molecules of nitrogen. And you use the same procedure to solve for each one. And for the other ones, again, we're going to have molecules of oxygen is equal to volume of oxygen times the number of molecules of air all over volume of air, which is 24, like that. 94.24. 94 times number of molecules, which is 2.46 times 10 to the 22nd, all over 1 liter, which gives you 5.15 times 10 to the 20th molecules of oxygen. And also you do the same thing for each one. CO2. And we have 0.0005 times the molecules all over 1 liter, which gives you 1 times 10 to the 19 molecules of CO2. And I'm going to do it in this little section over here for the last one, which is argon. Molecules of argon is equal to the volume of argon, which is 0.00093 times molecules all over 1 liter, which gives you 2.3 times 10 to the 20th molecules of argon.